Good afternoon, class. I had some students reach out to me because they were a little confused still about how to finish this project, Project 2. What I'm going to do is put together a short video laying out some of the basics of the code. I am not going to do the entire project for you, but I'm going to lay out the basics of it for you, and we can kind of talk through what that means in this video. You will be required to fill out all of the other pieces of code, the other code logic. So you'll find in this demo, I'm going to put some comments and say, now you implement the code here with this method or class that's stubbed out, okay? So let's go ahead and jump into IntelliJ. And one of the things I want to quickly show you here is when you do this project, it's probably to your benefit to create this as a distributable jar file. So the way I want you to do this is, first, I want you to right-click on the source directory, and I want you to create a package, as you can see here. When you create the package name needs to be something that is symbolic of you. Most package names on the web are done in reverse order of a website URL. So for example, I have a website called mdrsolutions.com, and a package name would commonly be com.mdrsolutions. Okay, that's a common package name. And then the last part of that package name needs to be something symbolic to the type of application. So I'm going to call this player just player. Okay, we'll just call it that. Now I can tell you that for Indiana State University, where I work for full-time, they use a package name of edu.indstate. And then it's a subgroup called ICS or OIT or whatever, right? They use those package names in deliverable jars that they create because it signifies their organizational unit. And it's a good idea to do that when you're creating packages. Right? But for all intents and purposes, your package can just be one word, okay? I'm demonstrating here how you would create a full one. So we'll create that. Inside of our package, we're going to create a class, and I'm going to call this my app. And we're going to leave this as a very, very basic class. All it's going to have is a public static void main method, and it's going to call our PlayerHealth class, okay? And so I'm going to type this in here even though the PlayerHealth class does not exist yet. So I'm going to say PlayerHealth equals new PlayerHealth. Okay? Again, this class doesn't exist, but we're about to create it. So right underneath our package called player, let's create a class, and we'll call it PlayerHealth. And if we go back to our app, because PlayerHealth now exists as a class in the same package, you don't have to worry about doing the import. If PlayerHealth existed in a different package, or if a class exists in a different package, then that's where you would have to put a import in here for, you would say import com mdrsolutions PlayerHealth, right? But because PlayerHealth exists in the same package, this is redundant. If it doesn't exist in the exact same package, then you'd have to specify it here. Okay, so we're going to take that out just for a moment. Okay, now let's go to our PlayerHealth class, and I'm going to toggle back to our Project 2 assignment instructions here. And we can see that it says you'll create a class called PlayerHealth that includes 3 overloaded calculate point methods. Okay, remember what an overloaded method is, all right? So I'm going to grab these calculate hit point methods for an online fantasy computer game. The 3 overloaded methods will determine the impact cost of overall life of the individual player when struck by sword, spell, or hand. This is a text-based simulation using command line parameters. Okay, so let's look at the actual code requirement. So here is the first method. Okay, so let's copy that. And we're going to come over here and we're going to do public void calculate hit points, right? Let's look at the algorithm that is required. When the calculate hit points receives a single parameter, it represents the hit point cost of a hand strike. Okay, so hand strikes will have 1 parameter for the point level of the hand strike multiplied by 2% damage over overall health. This means that the hand strike will be added to 2% of the total life to determine the damage against the total health points and display the remaining health. All right, so here is the formula. Now, we're going to have to create some global variables here to handle all this because some of these don't exist. First of all, we're going to have to create a private double called total health, and I'm going to initialize it to 0 for right now. Okay, the other thing that we see here is we have what's called a magic number. And anytime we use a magic number, we want to store that as a global static final variable. So we're going to come up here and we're going to create a private static final. And what is this called? This is going to be, we're going to call it double. We'll call it damage. And this is going to equal 0.02%. Okay? All right. So I'm going to replace this here with the variable damage. All right. And I'm also going to make this not a public method. I'm going to make it a private method. Okay? Let's go back to our code base again. Then we need to create another one called calculate hit points. This is hand strike and sword strike. Okay, so we're going to come back again. Come over here, and we'll say private void, right? We're creating some overloaded methods, and we're going to grab the sample algorithm again, paste it in. It looks like I messed up my spelling here, hand strikey. Oh boy. All right, so we're going to change our magic variable again to damage. And then the third method we have, third overloaded, is hand strike, spell type, and spell power. Okay. So let's go ahead and do private void all of this again. Let's come over here, grab our sample algorithm. And change that again. Okay. There you go. We got to convert the mathematical operation by putting the asterisk beside it. If you're doing regular math, you don't have to have that, right? Because you know automatically that this variable is going to multiply against it's going to multiply once this is done. But in Java, we got to be more explicit. Okay, again, we're going to change this to damage. Okay, we got our 3 overloaded methods. Final requirements, total health points will start at 200. Double total health 200. Well, let's go back and look at it. Double total health, well, there we go. Let's set it there. Okay, so we've got some of the basics of our class set up. And then we're looking at each method call, total health is smaller and smaller amount based on what happens. Okay, so the amount of total health is what is used by the next overloaded method. By the end of the 3rd method, see what it will take to deplete the total health points. Okay, so we are trying to go against this person, right? And we're going to use different methodologies to do that. So we're going to create these variables here at the top. We'll just say public static, right? Final int. These are the values of different things that are going to happen. Okay? Different things available for attacking the player. Now we have to set up how, here we go. I called it damage, but it's actually life cost. Let's go back and change that. So damage, let's see. You use Command R, you can change it all in one go. So Command R, and this is life cost. Oops. Okay, so now this is the basics, right? This is the basics of where our methods are stored. And we're going to call these methods, and it's going to change the total health. Let's go ahead and make these public again. I'm changing my mind on some of this. Okay. Now, let's come back over here. Remember to avoid magic numbers instead of using mysteriously encoded, right? 0.02. Declare the name, constant final, double life cost, and use that. Same would be true for spells, sword, and whatnot. So we get all of these different variables. Have fun with it. If you're wanting to make it interesting, figure out how to include math.random to make your game more dynamic. For this and all programming assignments, you'll have to turn in your Java source code. Make sure to include a comment block with the name of the file, your name and date. Apologies of the video live coding apparently was done with no audio. Okay, so this is an older one, but of course I'm including the coding example here for you all. Okay, let's go back and look at this. Right now we just have a class with different methods in it. So we need to have some methodology to activate it, right? So it's player health. Let's do this. Let's create another method and call this player menu. Okay. Now, we're trying to think how we're going to use this in how to use the math.random. So let's just first set up the menu, okay? Public void menu. We're going to instantiate our scanner class. We'll call this input equals new scanner. And this is going to take system.in All right, and let's lay this out now. We're going to do system out print line. Welcome to the game, to the player health game. All right. System out print line. The goal of this game is to, in as few moves as possible, cause the player's health to be depleted. Okay? So this is where we would ask for input, and we would try to set up some type of methodology. What we're going to ask the user, whoever's playing the game, to use. So let's go ahead and set up some basics here. We're going to keep one system out print line blank because I want this to be a line space for us. So we'll say system out print line again. Please choose your attack methodology. And this is where we'll think about our three methods. So in our player health, we can use calculate hit point with a hand in strike, calculate hit points with a sword strike and a hand strike, and this is a hand strike and spell power. All right. One for hand strike, system out print line, 2 for sword strike, system out print line, 3 for spell, 3 for casting a spell. Okay. All right. So this is where we would, and then we'll do. Let's do this. System out print line, 9 for exit. Exiting game. Now, I'm going to call this in a while loop, and I'm going to say while it's true, okay, because I want this to keep running no matter what until we exit. And I'm going to use a try catch block for input mismatch exception. And I'm going to say system out print line invalid choice, please try again. Now, by doing this, we're in the for loop, and so if someone enters something here like, let's go down here to our input. Let's say input.next int, and this is the int choice. If they choose something that is not a type of number, this is where this input mismatch exception is going to occur, and it'll it will exit them back out of this, back into the loop, and say, hey, you got to choose again. Okay. Now, for our purposes, it might be better to take this and put it at the top, because maybe we don't want to see the welcome to player health every time. Let's just kind of keep it like this. All right. So now we've got our choice, and we need to construct our logic. Let's say if choice is equal to 1, then what are we doing? If choice is 1, then it is the hand strike. Else, if choice equal to 2, this is the sword strike. Else, if choice is equal to 3, this is casting a spell. Else, if choice is equal to 9, then system out print line, goodbye, and break. Okay, let's see here. Let's change our true to a variable that we want to set to false if we want to exit. So let's do Boolean run equals true. So as long as run is equal to true, we're good to go. And we're going to say run is equal to false here, and we're breaking out of the loop. Okay. All right, so we got those stubbed out for us. And if by some reason there is wrong input, the exception will catch it. Okay? All right, so we have the 3 types. Now let's think about this. How are we going to use some randomization in here, right? There's a couple of ways we could do this. We could set, we could create a private void, let's say private double calculate hit points, and let's just pass in a scanner. Input and int type of attack. Okay. All right, so let's do it like that. So what we want to do here is we want to think about, at this point, if calculate hit points, we pass in our input and we pass in the choice, right? And we could do that for all of these. And because this is going to return our total health, we could just simply say system out print line, total health is now depleted to total health, right? And probably, to make this a little bit easier, let's just do this. Let's put do that. Okay, and then we're going to only worry about displaying the message at the end of these if-else statements. Okay, so we're going to copy these and put them in. All right, so we're delegating the logic out, but we're also kind of keeping ourselves from coding too much here. Okay, and system out, print line. Let's keep track of our attempts. I think that's a good thing to do. So let's say int attempts equals 0. Okay, and at the bottom we'll do attempts plus plus. All right. You have used attempts. You've used 5 attempts. Okay. All right. So let's think about now, how do we add the randomness to this? Okay. We know that the scanner is going to be passed in. We know that we're going to get the choice of hand strike or whatnot, and we also need to call that player health method. So let's instantiate our player health. We're going to do a private player health equals new player health. Okay. And down here, we have our player health, and we have calculate hit points. Okay, so let's make this a little bit random, right? We've got these ideas here: longsword, kung fu punch, iron punch, right? How do we make those a little bit more random? So we have these options here, but what does that mean, right? How do we know randomly how we're going to use them? Well, one way that we could do this is we could load these in a map, right? So we could do, let's do that. Let's create a map up here. And we're going to say map string and then the int. And I think we have to do this as integer. Okay. Now a map is what we call an associative array. So it's basically a key value pair that you store in a collection. So let's do it this way. We're going to have map, and we'll call the map possible attacks equals new hash map. Okay. And to make this work, I'm going to create a player health constructor. Okay, default constructor. And I'm going to make this public, by the way, so we can access it. And in our player health constructor, we're going to store these values, okay? So we're going to call possible attacks put, and we'll say long sword, and that's going to be a long sword. Possible attacks put kung fu punch, and that's going to take a kung fu punch. Possible attacks put I just had a thought. By doing it this way, I'm not going to be able to grab randomly what I want, and I want to only pull from one of those three possibilities, right? Sword, punch, or spell. So let's think about this again. Let's call this possible, we'll call this possible hand strikes. Possible sword strikes, and possible spells. Okay, so this one is going to be a sword strike. A kung fu punch is a hand strike. What's something else we got up here? Hand strike. I'm reusing these I've got in my code up here, so we're doing this as we go. Iron fist punch. Okay. Possible hand strikes. We don't have any more hand strikes. Possible sword strikes. I don't have any more sword strikes, but I need some to make it random. So let's create another sword up here. Ninja sword. Let's make that like 15 or something. Let's do one more. Let's make this a Minecraft sword. We'll give that 1. We've got Kung Fu Punch, Iron Punch. Let's do one more. Let's do a Fire Punch. Fire Fist Punch. We'll make that a 20. And we're going to have 3 spells as well. Tornado, lightning. How about we'll make this spell the vomit. Spell vomit. And I can't spell vomit. Okay, there we go. Vomit spell. All right, so we got all of these in here. Now I'm doing this because I'm trying to demonstrate a way that we could do this with randomization. So we got long sword, Kung Fu Punch. This one was Fire Fist Punch, right? So we'll do Fire Fist Punch. Oops, this is Hand Strike. Okay. Possible Sword Strike. What else do we have? We had up there, we had Minecraft Sword. Okay. Possible Sword Strike. Put, what was another one? The Ninja Sword. You can call these whatever you want, right? This is just a way to make it random so that we add a little bit of difference to this. All right, so let's put our spells in our maps. And what spells do we have? We have a spell tornado. Possible spells. Put spell lightning. Possible spells. Put spell vomit. Make the person sick. Okay, so I've got these. These are all different ones, right? We got 3 different swords stored in here, 3 different hands, and 3 different spells. And this is the way this is set up. All right, so let's go back to our player health. Now we need to think about how we're going to call what this is. So let's say if type of attack is equivalent to, what's a type of attack? Well, we have our numbers, right? A hand strike. So a hand strike is 1. If else, else if type of attack is equivalent to 2, which is the sword strike, else if type of attack is a 3, it's a spell attack. All right, let's do our randomization. So we're going to do math.random Okay. So the idea here is that we're going to generate a number between 0 and 3, and we're going to take whatever that is, we're going to add 1 to it so that we don't get 0. We want 1, 2, 3. Okay. All right. So that's going to be our random sequence. So if it's a type of 1, then we're going to say, hey, player health, possible hand strikes, let's see here. Let's do this. Player health, possible hand strikes, key set, let's see, we want okay, it's going to give us a set, and this is going to be strikes. Let's do this again for the next one. Player health, possible sword strikes, key set. And this is going to be swords, player health, possible spells, key set. Spells. Okay, so now we've got the keys out of those key value pairs, which would be the strings, right? So there's going to be 3 in each one, and we're going to get a random number from each set. So if the type of attack is a 1, which is basically a hand strike, this here is a sword strike, and this down here is a spell strike. All right, what do we get? Well, what we get is we're going to take our strikes and we're going to get, let's say strikes, and okay, what we're going to do is, now that we have, we're going to redo some of this. We're going to call this a, let's see here. How are we going to do this? I'm going to refactor this because I'm doing it as I go on the fly, so this is not, it's not a straightforward task. So we're going to call this a list of string, and this is going to be our strike list equals new array list, and inside of that we're going to pass our strikes, and I think we have to do this right here. Yep. And same thing right here, we're going to do a list of type string. This is our sword list equals new array list, and this is going to take our swords. And then finally we have list of string spells equals new array list, and that's going to take our spells. Let's make sure we call this spell list. There we go. All right, so we have these lists, and what I want to do is I'm going to grab, using the random number, one of those, right? And I'm going to take my strike list and do a get and pass in the integer, my special num. Okay, and what that's going to give me is a Should give me a string. We have to cast this as an int though, so let's do this. Okay, and that'll give us a string of whatever that strike is. Now that we have the strike, okay, I'm going to call the player health again, and I'm going to say for possible hand strikes, get, right? All right, and we're going to basically call get, and we're going to pass in the string. And that's going to give us, of course, the value of that attack. Attack value. And it's here that we can call player health, calculate hit points for a hand strike. So we're going to pass in what that is, the attack value. Okay, this is kind of complex because I'm trying to find a way to randomly generate this, right? So next we'll do this again, and we can copy most of this. Let's just do that, and we'll change some of the parameters. Here we're not calling the strike list anymore because we're doing a sword. So we're going to get the sword list. You're going to get the special num, and then player health, sword strikes. We get that value, right? And then calculate hit points for sword. That is the next one, right? Yeah. So we're going to pass in a hand strike and a sword strike. Well, that means we got to pass in two values. So let's do this for now. We'll do attack value. But it means I also need to get the sword strike value. So I also have to do this again. So let me copy this, and we're going to set this up like this. Okay, so we got, this is the hand strike, and this is the hand strike value. Okay, so if we lay this out again, this is my hand strike value, put it in there, and S is my hand strike, because I'm trying to get that from this hand strikes class. All right, last one is the sword strike. So let's copy this piece again. I'm going to change this to the spell list and possible spells, right? And then finally we have whatever our calculate hit points is. All right, so what is this? Well, if we look at the options for, that is hand strike, spell type, and spell power. Shnikes. All right, so we're going to need to copy this information again, because I need it down here for getting the hand strike as well. Okay, and the first variable is the hand strike, and then the second variable is the let's change this to spell attack value, right? What goes in here? Let's look at our options again. Spell type. Okay. That's the spell type, because I don't know what it is. And then we're going to throw in, because we're randomizing it, right? We're going to throw in some number. Well, what is the number we could put in there? We could generate another special number. Say final double special spell attack, and we could say math.random, and we could do this times 10 and do +1, right? And we could force this, by the way, to be an int so that we're done with that, okay? All right, so then down here, we could do special spell attack. And what is it complaining about? Int spell power. Okay. It's complaining because it still thinks it's a double. All right, so we're just going to cast it. All right, so we've got most of this set, right? We got a player menu. Looks like there's an error somewhere. Where's my error at? Oh, there we go. Got the player menu set. Got another error. Where's that error at? All right. This is where it needs to return player health. So we're going to say player health total health, right? Well, what are we missing? I bet you this is a private variable, right? Private double player health. So we need to create just a method down here called, we could do it like this. We could say, could generate a getter for total health. Now if we come back to player menu, we could say get total health, right? And this is where we have to return it because this returns that. All right, is everything tied in together? It looks like it is, except our app. We're not calling player health from here. We're actually calling player menu. And play menu. Okay, we really need to test this because I don't know what it's going to do. Let's test it and see what happens. Okay, so we have some options down here. Please choose your attack methodology. Let's first make sure that we're catching errors. If I pass in G, invalid choice, please try again. Good. How about 9? Does that exit? Yep, it does. All right, good. Let's run it again. Now run through some of our scenarios. So we've got, how about a hand strike? We do that, we got an exception. Index out of bounds on 65. All right, so what is it returning? Let's put a breakpoint and let's see what's being returned here. Okay, we're going to go back to player health and we'll right click here and debug. Hand strike, we hit it. And what is special number? Special number is that 1. And strike list has 3 values, 0, 1, 2, and 3. And in this instance, if we step through it, I think I know what I did. It'll work fine now because the value it gives from the strike list for S is Kung Fu Punch. Okay, we're adding a 1 to this somewhere. Where were we adding the 1? Right up here. We don't need to do that. We'll take that back out. Okay, this one's fine. but up here we don't want to add the 1. And the reason we don't want to add 1 is when we look at lists, they all begin 0, 1, 2. So if we set our count wrong, then we're going to get index out of bounds every time. All right, let's go back to app. We will run this again. We'll do 1. Player health is now depleted to negative 195. Well, that was pretty drastic. Let's do 2. Player health is now 212. Either we're going down or going up. 3. Player health is now depleted to 143,922. All right. Let's go ahead and exit the game. Let's go back to our player health. This is total health. We're taking this value minus total health, right? So let's put some breakpoints in here to see what is happening, all right? Because something bizarre is going on. We're going to go back to app. I'm going to debug this again. I'm going to press 1. We're hitting our breakpoint here. I'm going to take that out and resume the program. All right, so here is the first call. So right now the hand strike is 20, right? That's the value that's coming in. And the life cost is by that times the total health of that. So let's go back to player health. And what is this? The total amount of that. If we hover over this, it should tell us. All right, so life cost is that. Hand strike is there. So let's hit this. Something with our algorithm might be broken here. Okay, we're subtracting this from total health, right? And let's stop the program. Let's break our algorithm out to something that we can see a little bit better here. So let's say total health, and up here I'm going to do double cost equals, and I'm going to take this section here, put it to there, and then I'm going to put cost below, and let's run it again. Now if it does turn out that our calculation is off, then this is where you need to fix it. I'm not going to show you how to fix the math of these, but this is where you're going to need to think about what needs to change. All right, so we're going to debug it again. I'm going to come down here and press 1. We're getting the total. Did I not put a breakpoint? I didn't put a breakpoint. Let's exit that again. Go to app. Debug. 1. Okay. Step over this. We see that the cost is 24. Right. So do we understand what's happening? Cost minus total health, that's where it's going to give us the negative number and throw us off, right? Okay, so you're going to have to think about rewriting the algorithm here to fit better, right? Things like that. I could change this one entry, but you now need to come down here and change the following entries. Okay? Make sure you change the following entries to address that. I'm going to run the program again, and we're just going to run it based on just on hand strikes. Okay? So we run it again. Okay. Total health attempts 186. 2 attempts 172. Total attempt 167. 154. Right? We're keeping track of our attacks. So far, we're so good, right? All right, now let's go ahead and exit the game. You'll notice I have the attempts here, right? Let's add one last piece to this game. Right now, the attempts is that, right? Let's go over here to player health, and let's set another variable, and we're going to call this private static. Let's do public static final int max attempts, and we're going to say this is 6. You have 6 attempts. Now if we come over to player menu, what we can literally do here is we can add this and say you've used so many attempts of player health Did I not save it? Public static final. Oh, we can access it another way. Player health, max attempts. Okay? So, in our loop, once we get to the bottom of the loop here, right? Here's our loop. And we could say if attempts is greater than or equal to player health max attempts, okay, say system out print line, you have exceeded the allowable attempts system out print line, your final score is, and we could do player health, get total health, and then we need to set run to equal false, and then break. All right, let's run this again just using just the hand strike. So we do 1, 2, 3, 4, 5, 6. You've used your 6 attempts. Your final score is 118, and then it exits the game. All right, now let's go ahead and do the last part. How do we go ahead and make this this project where we can distribute the jar? We go to project structure, artifacts, click this, go to jar, from modules with dependencies, we're going to select the main class, which is automatically there. And click OK, click apply, click OK. Then we're going to go up to build and build artifacts and build. Now, you're going to notice real quick down here in the bottom, it built it very, very quickly. But if we go to the out directory it created, we'll see the artifacts, and there's our player health. Come down here to terminal, and let's cd to the out, artifacts, player health jar. There's the jar. Let's type java-jar player health and hit enter. And the application's ready to go. That's it. Now you need to make this your own. If you don't try to copy everything I've done here, make this your own. Show me your expressiveness and how you create it. Okay.